Marie Curie was a pioneering scientist whose work changed the understanding of matter and energy. She is known for her fundamental contributions to the study of radioactivity, a term she introduced, and for becoming one of the most influential figures in modern science. Her achievements placed her at the center of major scientific developments of the late 19th and early 20th centuries, and her legacy continues to shape research, medicine, and education. She was born Maria Salomea Sklodowska in Warsaw, in what was then part of the Russian Empire. Her family placed a strong value on education, although their circumstances were often difficult. Her father was a teacher of mathematics and physics, and her mother was an educator as well. During her early years, she experienced personal loss, including the death of her mother and one of her sisters, events that shaped her resilience and determination. During this period, opportunities for higher education for women in Poland were extremely limited. As a result, she took part in informal educational networks that operated outside official institutions. She worked as a governess to support herself and to help finance her sister's studies while continuing her own education independently. These years were marked by disciplined self-study and a strong commitment to scientific learning. Later on, she moved to Paris to study at the University of Paris, often known as the Sorbonne. She enrolled in courses in physics and mathematics, where she distinguished herself academically despite financial hardship and challenging living conditions. She earned degrees in both subjects and began her early scientific career in an environment that encouraged research and innovation. During her studies, she met Pierre Curie, a physicist already recognized for his work. They married and formed a scientific partnership that would become central to her later achievements. Together, they shared an intense dedication to research, often working under modest laboratory conditions with limited resources. As her research progressed, she became interested in the radiation emitted by certain elements, building on earlier discoveries by other scientists. She conducted systematic measurements and identified that the radiation was an atomic property, independent of the chemical form of the element. In addition, she introduced the term radioactivity to describe this phenomenon, giving the field a clear scientific identity. Working closely with Pierre Curie, she investigated minerals containing uranium and discovered that their radiation levels were higher than expected. As a result, she concluded that these minerals must contain previously unknown elements. Through careful and labor-intensive work, the Curies identified two new elements, which she named polonium, in honor of her homeland, and radium. These discoveries had a profound impact on science. They demonstrated that atoms were not indivisible and that matter could transform in ways previously unimagined. The work also laid foundations for future research in atomic physics, chemistry, and medicine. In recognition of these achievements, she shared the Nobel Prize in Physics in 1903 with Pierre Curie and another scientist. This made her the first woman to receive a Nobel Prize. Despite this recognition, she continued to focus on research rather than public attention. During this period, her life was marked by personal tragedy. Pierre Curie died unexpectedly in an accident, leaving her to raise their children and continue their scientific work alone. Later on, she accepted a teaching position at the University of Paris, becoming the first woman to hold such a role there. She continued her research with determination and achieved further recognition for her work. In 1911, she received the Nobel Prize in Chemistry for the discovery of two new elements and for isolating radium and studying its properties. This made her the first person to win Nobel Prizes in two different scientific fields. In addition to her laboratory work, she contributed to practical applications of science. During the First World War, she promoted the use of mobile radiographic units to assist medical diagnosis on the battlefield. She helped train personnel and supported the development of these techniques, which improved the treatment of injured soldiers. In the years that followed, she led research institutions and promoted scientific education. She was involved in establishing research centers dedicated to the study of radioactivity, including institutes that later became important centers for nuclear and medical research. Her work influenced both scientific practice and public understanding of science. However, her long-term exposure to radiation at a time when its dangers were not fully understood took a toll on her health. She suffered from chronic illness in her later years, which limited her ability to work. She died in 1934 from a condition now associated with prolonged radiation exposure. Her historical significance is substantial. She advanced fundamental knowledge of atomic science and opened new paths for research and medical treatment. She also challenged social barriers, becoming a symbol of scientific achievement through perseverance and intellectual rigor. Her legacy continues through institutions bearing her name, through the scientific fields she helped establish, and through her influence on later generations of researchers. Her story demonstrates how careful observation, sustained effort, and commitment to knowledge can produce lasting contributions to humanity. In closing, Marie Curie remains a central figure in the history of science. Her work reshaped scientific thought and practical medicine, and her example continues to inform educational and research traditions around the world. Her story stands as a lasting record of dedication to discovery and public service.